Okay, good morning. This is PreCalc section P2, Cartesian coordinate system. At the end of these notes, I'll be able to plot data on the Cartesian coordinate plane, use the properties of absolute value, no one used the distance formulas, no one used the midpoint formula, no one used the equations for circles. First thing we're going to look at is just a review of the Cartesian coordinate plane. Remember quadrant 1, quadrant 2, quadrant 3, quadrant 4, the origin, we got the x-axis, we got the y-axis. Okay, the Cartesian coordinate plane is named after French mathematician René Descartes. So the rectangular coordinate system is, he's the one that's responsible for it. Now let's look at an example. We've got some data plotting. Keep in mind this is all in quadrant 1. The value in billions of dollars of U.S. exports to Mexico from 2000 to 2007 is given in the table, P2. Plot the year export value. I've got my export values here, so this is my export values, and these are the years. Okay. Order pairs in our rectangular coordinate system. So we've got this going, and my data looks like this. Okay. Now, a scatter plot is a plotting of data pairs, x, y, on a Cartesian coordinate plane. We just created a scatter plot of the data for U.S. exports to Mexico. Now we'll be representing a lot of information as graphs, and we'll do scatter plots. We'll also be doing some stuff with your calculator and some regression analysis. But for right now, just basic scatter plot graphing, XY coordinates, and being able to put it on and be able to show your data on a table, from a table. Okay, so going on, the absolute value of real numbers suggests its magnitude or size. The absolute value of 3 is 3. The absolute value of -5 is 5. It's just the distance it is from 0. Now this is the definition of the absolute value of real numbers. The absolute value of A, it's A if A is greater than 0. It's the opposite of A if A is less than 0, and it's 0 if A is equal to 0. So, if I'm looking at the absolute value of -5, I will go the opposite of -5, and it'll be 5. And most of you are just looking at that idea of the distance it is from 0. And what we'll do is I'll show you my answers based on the definition today, but in general, I will always do that absolute value, or the distance it is from 0. Using definition of absolute value, notice using the definition. So by definition, since this is negative, I'm going to be talking, so if -4 is less than 0, and it is, so I'm going to find the absolute value of -4, which I'm asked to do the opposite of the -4, and it is 4. Now, pi minus 6 is less than 0, because pi is 3.14 minus 6, so it's a negative value. So again, I've got the absolute value of pi minus 6, and it's equal to opposite of pi minus 6, which is the opposite of pi plus 6, or I can say 6 minus pi, which ends up being about 2.858. Now, there's properties of absolute value. We can let A and B be real numbers. The absolute value of A is greater than 0. The absolute value of A times B is equal to the absolute value of A times the absolute value of B. Now, the absolute value of the opposite of A is just A, or the absolute value of A. And the absolute value of A over B can be equal to the absolute value of A divided by the absolute value of B, assuming, of course, that B is not 0. Okay, little review of distance formula. When we're looking at distance in one space, it's not just on a number line. The distance between A and B is the absolute value of the difference of their coordinates. Okay, now so I can find two values on the number line in the absolute value, whether it's A smaller than B, or B's bigger than A, or B smaller than A. Doing the absolute value will work. Note that I can do it either order. It doesn't matter. Because of the absolute value, it'll always be a positive answer. The distance between -1 and 4 on the number line is 5, because -1 minus 4 is -5, the absolute value of which is 5. 4 minus the -1, 4 plus 1 is 5. The order of subtraction does not matter when we are using absolute values. So if I'm using this, if I got -1, just to emphasize this, and I've got -4, or excuse me, +4. This distance, 1, 2, 3, 4, 5, it makes sense that it's 5 as we plug that through and get that done. Distance formula for the coordinate plane. Hey, x sub 1 minus x sub 2 quantity squared plus y sub 1 minus y sub 2 quantity squared, all over the top of the square root. And a lot of folks get confused about where this stuff is coming from. You remember the Pythagorean theorem, because we're finding the distance from Q to P or P to Q, that's D. But really, I'm looking at an A, B, and C on the Pythagorean theorem, where y minus 1, y minus 2 can be B, x minus 1, x sub 1 minus x sub 2 is A. Now I square them according to the rules here. When I square them, my absolute value doesn't matter any longer. Take the square root, because I just want to find the distance between the points, and that is the distance formula. Now, derive the distance formula, use the above visual in the Pythagorean theorem. I think we've already done that. Look, it's up there. Okay? I have more hair than that. Anyways, I hope that went well. If you have questions on the derivation of the distance formula, let me know. Okay, finding the distance between 2 points. Again, we have the distance formula. This is x, this is x. So I'm going to find the difference of the x's, the difference of the y's. I'm going to square the difference of the x's, and square the difference of the y's. Find that sum and take its square root. Okay, and that's going to be 25 plus 9, which is the square root of 34. And I pop it in my calculator, I get 5.831. Now, next thing, midpoints. Midpoint formula is just the average of the two values that are there. If it's in one dimension, just on a number line, a plus b divided by 2. So if I have the midpoint of a line segment with endpoints -9 and 3 on the number line, I take, and again, I'm doing a plus b over 2, the average of those values. So -9 plus 3 divided by 2, okay, it's going to give me -3. So that's the midpoint. And if I look this up, I've got my midpoint here at -3. I got -9, I've got 3, midpoint at -3. Now, all this stuff, I hope you're hearkening back to geometry, the midpoint formula on the coordinate plane. Hey, look at this. I'm going to take a plus c and b plus d. They kind of funk this up a little bit with a, c, b's, and d's. Really, this is the average of the x's and the average of the y's. So pay attention over here. Let's follow the dotted little line and go, hey, look, from geometry. Average of the x's, average of the y's. That's it. That's midpoint. Okay, so if I have 2 points, -5, 2, 3, 7, I take my x's, -5 and 3. Okay, according to what they say up here, midpoint, I got -5 plus 3. Okay, and I've got 2 plus 7 because 2 and 7 are the y's. Okay, I add those together, I get 2 divided by 2, -1, -2, excuse me, divided by 2, and 2 plus 7, which is 9, divided by 2 is 4.5. When using midpoints, think average. Equations of circles. Oh my gosh, we're back still in geometry. And remember, we've got a circle. It's got a distance from the center, which is r, its radius. There's a point here on the center, which is hk. As we're going through, we have hk as the center and xy going up. And we have x minus h is this distance. Y minus k is this distance. Okay, so as we're looking through this, that looks kind of like the Pythagorean theorem. I wonder, see, this was looking like I'm going to square this and find a distance, which we're going to call r. Well, I get this going because, pop in these things. This is going in for my x's, this is going in for my y's, and I square both sides, and holy bananas, look at that. I've got the general equation for standard form for a circle. Check it out. We just derived what a circle equation was. Crazy. So you should be able to recall that just based on the distance formula. So we're going to find the standard form of the equation of the circle. Remember, the center is hk. So if I'm looking at the standard form here, find the standard form of equation of the circle. I have a center, -4, 1, and a radius of 8. So my center, which is hk, my radius is r is 8, I just plug in my values. So I got x minus a -4. -4 goes in for h, 1 goes in for k, 8 goes in for r. And then I just evaluate, kind of clean things up, make it look pretty. So I have the quantity x plus 4 squared plus the quantity y minus 1 squared equals 64. Hey, it's your turn. Give B a try. Standard form. 0, 0, 5. Hey, it's x squared plus y squared equals 25, and we've written our equation. Using an inequality to express distance, we can state that the distance between x and -3 is less than 9 using the inequality. Okay, the distance between x and -3, so x minus a -3, that's the distance between x and -3, is less than 9. We can clean that up a little bit by just adding opposite here and saying the absolute value of x plus 3 is less than 9. Pythagorean theorem and its converse are both true. If the sum of the squares of the lengths of two sides of a triangle equals the square of the length of the third side, then the triangle is a right triangle. End of story. So verifying the right triangles. Use the converse of the Pythagorean theorem in the distance formula to show that the points -3, 4, 1, 0, and 5, 4 determine a right triangle. Well, the first thing I have to do is find these lengths. After I do that, I'm going to use these lengths in the Pythagorean theorem to see if this is truly a right triangle. Because if 3 numbers work in the Pythagorean theorem, it is a right triangle. And if those 3 numbers are integers, those 3 numbers would be considered a Pythagorean triple. But let's go check out what's going on. So we're going to find the distance between -3, 4, 1, 0, -3, 4, 5, 4, 1, 0, and 5, 4. So to find the distance of the first, I get the square root of 32. I'm going to leave it that way because there's a lot more value left in there instead of me rounding using my calculator. Same thing here, finding the distance. I get it as 8. And same thing here, 1 minus 5, 0 minus 4. And I get the square root of 32. So far, I'm pretty confident that this triangle is isosceles because 2 sides are the same length. But let's check this out. If the 2 sides that are the same length, I'm going to use those as my legs, and it kind of makes sense because -3, 4, 1, 0 and 1, 0, 5, 4 would be the ones that I would think that would make the right triangle as I sketch this out rudely, kind of roughly, not rudely, but roughly up on top. So let's check this out in the Pythagorean theorem. Square root of 32 squared plus the square root of 32 squared equals 8 squared. Hey, 32 plus 32 is 64. It works. So I'm supposed to use the converse to determine a right triangle. It works. This is a right triangle. And maybe this is a right triangle. Yay! Okay, let's move on using the midpoint formula. Okay, it is a fact from geometry that diagonals of a parallelogram bisect each other. Okay, so prove this with a midpoint formula. Okay, we're really proving that this is a parallelogram by showing that by midpoint formula, these 2 diagonals have the same midpoint. If these 2 diagonals have the same midpoint, then it is either a rectangle or a parallelogram. Okay? But since a rectangle is a parallelogram, we're just supposed to prove that this is a parallelogram. That's our only concern. So find the midpoint of AC and OB. AC and OB. Midpoint of AC, A plus C over 2, B plus 0 over 2. So there's my midpoint. Midpoint of OB, okay, OB, 0 plus A plus 0, A plus C, and 0 plus B. Well, gosh, look, A plus C over 2, B over 2. Midpoints are the same, so guess what? Since the midpoint value for both triangles are the same, the diagonals are mutual bisectors of each other. So, therefore, it's a parallelogram. You have a 10th example in your notes, and for some reason this particular notes does not have it. Prove algebraically that a triangle determined by the following coordinates is an equilateral triangle. Well, all you need to do is show that length AB, length BC, length AC are all the same lengths. If it fails on any one of those using the distance formula, it is not an equilateral triangle. So it's an example that's very much like example 8, except instead of being a right triangle or showing that 2 of the sides are the same, all 3 sides would have to be the same, because example 8 was a example 8 was an isosceles right triangle, and we're looking at example 10. So what I'd like to do is do that together. I'll work that out and get that back up. I just don't have that slide on this. So we'll see what we can do, and I apologize for not having it. I hope things are going well. This is the assignment for page 17, P2. We're looking at 1 through 16, 19, 20, 23 to 28, 30, 33, 35, 36, 39, 42, 44, 45, 46, 50, 53, 60, 61, and 67. Obviously, you can see that right there. Have yourself a great day.